We'll be looking at the second section of object-oriented programming in Java, and what we hope to achieve today is do a review of what we did in the first part of object-oriented programming, and we'll also look into inheritance and its types, and also what polymorphism is and types of polymorphism in Java. And there will also be a brief explanation of the object class in Java. And we'll look into abstraction and interfaces and the differences between these two concepts. So these are some learning resources that can be useful during your further studies in Java, or just for further references. So Gigs for Geeks, the Oracle docs provided by Oracle Java, tutorial points, Java T-Point, and W3 School. So once you go to the object-oriented programming page, you'll see all the concepts that we've been talking about from last week as well. So we're going to go into the review now. And like I said last week, object-oriented programming is a way to characterize software programs with objects, so real-world entities like things you see around you, your bicycle, your car, you yourself as a person, your phone, just different things around you, and they're classified as objects that have states and behavior. You yourself as a person, in the world of programming, you're an object. You've got eyes, ears, nose, mouth, and you've got behavior as well, because you can walk, you can talk, you can eat, you can see. So these are you yourself. You are an object in the programming world. And we also took a look into what classes are. Classes are blueprints for objects. So what you want your object to perform, what you want your object to possess, you write that in your classes like a format for creating objects. We also looked into methods, which are a collection of statements that perform operations. So anything you want to do, like if you want to walk, you can put that in a method and perform some operations on that, do some coding on that in your method. And we also looked into constructors, which are a concept in Java that are used to construct objects and how you want your objects to look like. So you can have different kinds of constructor. You can have the one created, given to you by Java, or you can have the one where you define it yourself and you put what variables you want in the class. Then we also have getters and setters, which are methods that allow private variables to be accessed, promoting data encapsulation. So we don't want our variables out in the public like that. So we encapsulate them and keep them in the class, and we access them via getters and setters. So I've got an example on my right-hand side here, and this is my class user. My user has one constructor that takes in no parameters, and I've got three methods. So this is the user-defined method, update profile, and these are my getters and setters that I use to access my variables that are private instead of public. So my variables in this class doesn't leave this class. I only access them through my getters and setters. And to create a new object, I define this in the main class using user, which is the class name, the reference variable for my object, what I want my object to be called, and I use the new operator. This has to be used if you want to create a new object, and the class name with brackets. So today we'll be looking at inheritance, and this is a very important object-oriented programming concept that allows one class to inherit properties of another. So for example, if you want to create a class and you have another class that contains some properties that you want your new class to have, you can perform some inheritance relationship between the two of them, where your new class will get the properties from that class that you created, and they're classified into parent class or child class. So we've got super or base or parent class. This is the class that the properties are getting inherited, and the sub or child class is the class who inherits the properties of of the parent class. So it's just like a parent and child, where the child sometimes inherits some of the properties of the parents. That's why some people say, oh, you're so much like your mom, or oh, you're so much like your dad. So this is kind of like an inheritance relationship in Java as well. And also sometimes children, or most times, children inherit some things from their parents. So this is kind of like an example of inheritance in Java as well. And the kind of relationship inheritance has, or classes have between each other, is called an is-a relationship, or a parent-child relationship. So the superclass defines the commonality, and the subclass specializes the commonality. So the superclass is where you define the common things that the subclasses should have, and in the subclass you can add your states, you can, or behavior, you can override some methods in that class, in your subclass as well. And in Java, one thing to note is that a subclass has only one direct superclass, while a superclass can have many subclasses. I'll use parent and child example as well, as one parent or two parents, and I'll use one parent for example. A child only has one parent, but a parent can have multiple childs. That is the same with Java. A parent class can have multiple child classes, but a child class has only one direct parent class and cannot have two parent classes. And all the properties of the parent class belongs to the child class once a keyword is used, which is extends. So the extends keyword is used to indicate that that new class that you're defining derives the attributes from an existing class that has been made in Java. So why do we use inheritance? We use inheritance for our code reusability. We don't want to be duplicating code all the time, so we can classify some common codes together and put them in one class, and from there we can get the properties in child classes. And we use inheritance also for something called method overriding, which is when the child class has the same method declared in the parent class, but the implementation can change. This will be discussed later on in the class. So we'll look into examples of Java just to get a good visualization of what I'm trying to say. So we've got a class here, vehicle. Obviously, we can have many types of vehicle. We have a car, we have a truck, which can be another vehicle. We have a bike, which is another kind of vehicle. And we're going to create a class called vehicle and another class called child class. So the child class will get some properties from vehicle that will be used in its class. And also in the class diagram, as you can see on my right side, the extend keyword is used, and it's just showing that, oh, I'm getting all these properties in my new class. So give me all these properties because the extend keyword has been used. So we're going to create this class in our IntelliJ right now. So for this example, I'm going to start over again. As we've seen in this class diagram, we've got one field, which is the model, and it's the string. And we've got three methods, which is just the get and the set model for the string. And we've got another method called honk, which is basically going to honk. So I'm going to make my variable protected because I want my subclasses to be able to use that variable. This is why protected is very useful, because it limits access to only this class and the child classes. So this is protected string model, and I'm going to generate some getters and setters, a getter and a setter for my field. So I'm just going to right click on my computer, on my mouse, and create generate getters and setters for this module. So my getters and setters are created, and I'm going to create another method called honk. Doesn't return anything because, as we've seen in this class diagram, it is void. And it's going to say honk. It's not going to take in any parameters, and I will just put system.out.println vehicle is honking. So I will create a new class called car, and this is it here. And for me to be able to get the properties of vehicle, I have to put in the keyword extends vehicle. And because I put in this keyword, I can use the variables and the methods defined in vehicle. But first, I'll first define what my class should have. So I want my car to have two fields, a brand, which is a string, a color, which is also a string, and getters and setters for my color and brand. And then I want it to have the method that was defined here, which is honk. Apologies, that was a mistake. That should be honk. So I'm going to define my methods, which is private. It's going to be private because I don't want anyone to use it, any other class to use it rather. So I would access it using my getters and setters. Private string color, and then I'll generate my getters and setters. And then I'll create a main class now to be able to view what I have just created. So my class will just be main class. Now define the public static void main string as. And for this, in this class, I will create a new object, a new car object, so car. I want my car to be a Tesla equals the new car. And then car, if I do Tesla dots, you can see I have the module from the vehicle class. I can access the module from the vehicle class because the car has extended the vehicle. So because you put in this extend vehicle, you can inherit the properties of vehicle. So I can do Tesla.module.set module. I don't know, Tesla 1, 2, 3, and then Tesla.set brand, which is Tesla, and then Tesla dot color. Apologies, I did not generate getters and setters for color. So because I did not generate getters and setters for color, and because this is private, I can't access color here. Can't see anything related to color because it is private to car. So I'm going to generate some getters and setters for my color. Okay. And then I can use again. Set color blue. And then I can also call my my honk from the vehicle. So if I click Tesla.honk and I run this application, you can see that it says vehicle is running because that is what has been defined in the vehicle class. But I have used my car class to call it because I inherited that property. Now, if I want to make it very personal to me, I can write that, I can bring that class in, public void honk, and then change the definition to car is running. Or I can even make it more specific and say guess my brand, guess the brand of my car, and then say it is running. So if I click on honk, if I run this application in the main class, we'll see that this will change. So if I run it, because I've set the model here and the brand. So if I run it, you see that it says Tesla is running. And what has happened here is I have overridden the method that was written here. So I used the override keyword to override what was written in my parent class, and I made it special to me. I wrote what I wanted to see for my particular class. So if I create another class called maybe boss, and I extend the vehicle, I can personalize it and say, oh, get the name of my boss is running, and it will show the name of the bus that is running, if it's Toyota or something. So this is just the basic explanation of how inheritance works. You can inherit the property, which is the model. You can inherit a field, which is the model, or you can inherit a method, which is the honk. We've got 3 types of inheritance in Java. We've actually got 5, but in Java there are 3 types that are mostly used. The single inheritance, the multi-level inheritance, and the hierarchical inheritance. So in a single inheritance, one child class inherits the features of a parent class. So in this diagram here, we can see that there's a parent class called animal, and the dog extends and gets properties from animal. We'll do an example of each of the types of inheritance just to give you guys a better idea of inheritance and its types. So for this class, we've done kind of like a similar example in the previous slide, which when we did vehicle, but we'll do another example. So in this example, the parent class is animal and the child class is dog. So in my IDE, I'll create a class called animal, and then I'll just declare a simple method, public void eat, and then say system.ln, and then I'll create a new class called dog and extend animal if I want the property. So extend animal, and I'll also create a new method in my class, public void bark, because the dog barks. Barking. So in this animal class, eating is something common in animals. All animals eat, but dog is very specific. A dog can bark, a goat cannot bark, a lion cannot bark, a dog barks. So that's why it's very specific to that class. So if I go into my main class and I create a new object of dog, I want my dog to be I'll just be naming dog 1 because I can't think of any dog cats now. Because the new dog and then my dog 1, I can get some properties for my new dog, which is the new object I have created. So it will just be dog 1, and you can see that I have two of the methods. One was declared in the animal class and back was declared in the dog class. So I have access to both methods because I inherited some of the properties. One, the property eat from the parent class. So my dog can eat and my dog can also bark. So if I run this application now, you can see that my dog is eating and my dog is barking. So I can access these two methods, one from my actual class and one from my parent class. So this is an example of single inheritance in Java. The next type of inheritance is the multi-level inheritance. And this is 3 levels of inheritance. So I have a parent class and it has a child class, and that child class has another child class that is inheriting some of its properties. So my dog class is acting as a parent class to Puppy. So basically, the animal class is like a grandparent to Puppy, if you understand what I mean. So the dog class is the animal's child and the puppy is the dog's child. And like I said, yeah, a child class cannot directly access its grandparents' members. So my puppy cannot just go from year to year. It has to pass through my dog. So my dog inherits some of the properties of animal, and then my puppy inherits the properties of dog, which contains animal properties. I will give an example right now because I know that can be confusing. So I've got my animal here, which is animal, dog, and puppy. So we'll create 3 classes for this. We've created animal and dog, so we'll just create the puppy class. And we'll see how the inheritance works. So my animal class has one method called eat, and my dog class has another method called bark. And I have a puppy class here that will extend the dog class. That is the parent class to puppy. So extend dog. And I'll put a new method for my puppy. So I'll make it public void weeping, because a baby dog, a puppy, can cry or weep. Now just say a simple weeping ... And I will go into my main class now to create a new puppy dog, a new puppy class, a new puppy object. So it'll be puppy, which is the class, my dog, my object name, puppy1, equals to new puppy, and then I will see what my puppy can do. So as I've seen here, my puppy can weep, my puppy can bark, and my puppy can eat. My puppy can weep because that is the method I declared in the puppy class, and my puppy can bark because it is inheriting the properties of its parents in the dog class, which means dog can bark. And because dog extends animal, and as we've seen here, dog can eat because it extends animal, my puppy can also eat because its parents has inherited the property to eat from animal. Puppy1 dot eat. So if I run this, you should see, okay, weeping, barking, and eating. So my puppy can do all these three things because it's inherited a property from its parents, which is dog, and the parent inherits a property from their parents, which is animal. So because of that, my puppy has access to those two methods. And that is an example of multi-level inheritance. The last type of inheritance is hierarchical, which means two or more child classes can inherit from the parent class. And I've got in this example here 3 different kinds of animals. So a dog can inherit the property eat from animal, goats can also eat, and cats can also eat. But these 3 child classes can also have their different methods and fields that they can declare things in. So we'll create 2 new classes called goats and cats. Create a new class called goats and another new class called cats. And for my goats and cats, I'm going to make sure it extends animal. And I'm going to give it its own methods. So public void meow. And then it goes public void goat bleed. So name it bleeding. And so I'm going to create new objects of goats and cats in my main class, and we'll see what that can give us. Oh, the goat also needs to extend animal, or else it will not get the properties of animal. So I'm going to create a new goat, and it will be goats 1 equals new goat, and then goat 1 can bleed, and goat 1 can eat, and then a new cat 1 equals new cat. We'll see what our cats can do. Our cat 1 can meow, and our cat 1 can eat, thanks to it inheriting animal. So we're just going to comment this to avoid. And if I run this application, you can see that my goat is bleating and eating, and my cat is meowing and also eating. So this is just the 3 main types of inheritance that Java supports. Java does not support multiple inheritance in Java. Java does not support multiple inheritance because it is very ambiguous, and to reduce complexity and to simplify the language, you can only inherit 1 class. That is why I said a subclass can only have 1 direct parent class. So that's all for inheritance.